we're going to talk about the disk method. Here's your X and Y axis, and let's suppose we have that curve going from A to B. And we want to know what the volume is going to be if you revolve this around the x-axis. Well, we kind of have the mirror image. I hope you see that. And but basically, this is just going to be round. It's going to look something like that. Now, let us see how we might go about finding the volume from A to B. So V is so we're going to add up, so we know it's integral from A to B. Now, how about we make these strips horizontal? And it's almost a rectangle. It's almost a disc. Well, it's almost a rectangle. I mean, for small delta x, this curve up here is going to be horizontal. So it's going to be a rectangle. Now, when you take a rectangle, and you need to picture this, if you take that rectangle, that very narrow rectangle, and you rotate the y-axis, you're going to get a disc. You're going to get a disc, a hockey puck. You're going to get a disc. And what is the volume of a disc? Now, let me try to draw the disc a little bit better. It's going to look something like that. It's going to be a circle with some thickness. Well, the area of the circle is pi r squared. Times the thickness. The thickness is going to be delta x, excuse me. The thickness is going to be delta x. And in the limit, as we let delta x get smaller and smaller, it becomes dx. And of course, if we rotated this diagram so it's all on the y-axis, it's still going to be the same. It's going to be pi r squared times dy, and instead of a to b, y may be going from r to s. But nonetheless, these are the two formulas. Try to see it rather than just accept it. Okay, imagine this volume here rotating. If you rotate that line, okay, it's gonna become a circle with some thickness. Imagine just rotating this line. I mean, if you took a ruler, or if you took a pen or a pencil, and somehow you attached another pencil to it, and then you rotate this, and you try not to move it. But when you rotate it, this line will move. And, this tip up here is going to create a circle if you watched it. And this point here, if you watch that point, maybe you painted a bright color, is going to form a circle. When you rotate this here, that point's going to create a circle. So is this point and that point and that point. All of these points are going to create a circle. But the thing is, this is going to have some thickness to it. That's what makes it into the hockey puck. So disk, pi r squared times the thickness. Possibly you can look at your books for better diagrams, or you can look at a YouTube video where it's professionally shown how it looks like a disc. For us here, we're just gonna do some problems. Suppose you have the curve y equal 1 minus x in quadrant 1. And you want to revolve it around the x-axis. I mean, if I bring the x over, this tells me that x plus y is 1. Well, that tells me, remember, anything on the x-axis, y is 0. So x has to be 1. And anything on the y-axis, x is 0. So y has to be 1. This here is the line in quadrant 1. We said it's in quadrant 1. And we want to revolve this about the x-axis. Now, I actually want to draw this a little bit bigger. So 1 and 1. That's the curve. Happens to be a line, but it's also a curve in quadrant 1. Now, if you revolve this curve around the x-axis, if you go around the x-axis, what you are going to get is a cone. You are going to get a cone. And the question is, what is the volume of this cone? Now, there's two ways of doing this. The volume of a cone is 1/3 pi r squared h. Well, we know what 1/3 is. We know what pi is. We have to find r and h. Well, r is that distance. R is 1. You know what? The height of the cone is this distance. That's also 1. So the answer is just that. The answer is pi over 3. And we didn't even have to use calculus. But let us do this using calculus. Let us see if we can actually get the same answer. Let us see if we can get the same answer. So that's 1, that's 1. And we are revolving around the x-axis. And when you use the disk method, whatever line you're revolving around, the strips are perpendicular to it, right angles. So since we're revolving around that bottom green line, we're going to put the strips vertically. And the formula is pi times r squared, in this case dx, because that's a delta x, and x is going from 0 to 1. Well, what is the radius? How tall is this? Well, that's just the y value. The y value is 1 minus x. The y value is 1 minus x. So we set up the integral. Let's do it. I'll bring the pi out in front. So we have pi, the integral from 0 to 1. I'll actually square that. So I get 1 squared minus 2x plus x squared dx. Pi integral, just pi, and I'm going to actually integrate it. But somehow it looks like I lost that 1. So When I integrate it, integral of x of 1 is x minus the integral of 2x is x squared plus the integral of x squared is x cubed over 1 from 0 to 1. So the pi stays out. I put in 1 for x. I get 1 minus 1 because 1 squared is 1 plus 1 cubed, which is 1 over 3. So the 1's cancel out, and I get pi times the third, which is pi over 3. And let me mention that when I plug in the x, I'm going to get 0. That's why I didn't subtract. And if you notice, using calculus, I got the same answer. Pretty neat. Okay. Let's do another problem. Suppose that we want to know the volume that is generated by the region when we rotate around the x-axis by the curve 4 minus x squared. And like I said, we revolve around the x-axis and we're only in quadrant 1. Okay, so 4 minus x squared. Well, I know minus x squared is an upside down u where the highest point is at the origin. Just keep in mind, this is negative x squared and then add 4. So it's going to be like this. Okay. And we're only in quadrant 1. So I'm going to get rid of this. Now, the only area that's bounded in quadrant 1, that means bounded by the x-axis, the y-axis, the positive x-axis, the positive y-axis, and the curve 4 minus x squared is this area and there. Now, what are these values? Well, when is 4 minus x squared equal to 0? I hope it's clear that x squared must be 4, because 4 minus 4 is 0. So x is plus minus 2. This is 2. And if y is 0, if x is 0, I get y is 4. So let's draw this a little bit bigger. X is 2, y is 4, and we have a curve that looks like that. Oops. Looks like that. And we are going to revolve about the x-axis. We're going to go that way. So the volume is going to be, well, if we're revolving around the x-axis, the strips are going to be perpendicular to the x-axis. That means I'm doing dx. The volume is going to be pi times the radius squared dx, where the 2 is right there. The question is, what's the radius? And what's x going from? Well, the strips in quadrant 1 can go from where x is equal to 0 all the way up to x equals 2. Okay, now what is the radius? Now when you rotate around the x-axis, this height is going to be the radius. And the radius is always the top value minus the bottom value. But the top value is 4 minus x squared and the bottom value is 0. So when you subtract it, you get 4 minus x squared. This is equal to pi, the integral from 0 to 2. Let's FOIL that out. You get 4 squared minus 8x squared plus x to the 4th. And at this point, it's a routine integral. Just remember to multiply by pi on at the end. Integral of 16 is 16x minus 8x cubed over 3 plus x to the 5th over 5. And this goes from 0 to 2. So there's the pi. You plug in 2, you get 32 minus, you plug in 2, you get 8 times the 8 in front of it is 64 over 3 plus, you plug 2 in, you get 32 over 5. And when you plug 0 in, you're going to get 0 again. The common denominator is 15. So let me factor it out. So the first term, I need to multiply by 15 over 15. So I have 480. 15 times 32 must be 480. Here, I multiply top and bottom by 5. And 64 times 5, well, 5 times 60 is 300. 5 times 4 is 20, 320. And here, I need to multiply top and bottom by 3. Plus, 3 times 30 is 90. 3 times 2 is 6. So, of course, we get 96. Pi over 15. 420 minus 480 minus our 320, that's our 160. Well, if I add 100, I added 4 too much. So I have to take away 4 from the 60. Looks to me like 256. Now, the sum of the digits add up to 13. So 3 does not go into that, like it does into 5. And 5 clearly doesn't go into that number because it doesn't end in a 5 or a 0. So the final answer is this. Okay. Let us try another one. Okay. Suppose you are told that it's the area, you're going to revolve the area that is bounded by y equal x squared, y equal x cubed, and you're going to revolve about the x-axis. Okay. Well, you should know that y cubed is going to be down there when x is less than 0, and that our x squared is going to be up there. So any place where it's going to intersect, it's going to be in quadrant 1. This here is x cubed. This is x squared, x cubed, x squared. They intersect at 1 and 0. If these two, let me put the 3 here. If these two are equal, bring the x squared to the left side, get 0, factor out x squared, and then you have x minus 1. So either x squared is 0, that happens when x is 1, or x minus 1 is 0, that happens at 1. So the curves intersect at 0 and at 1. Okay. And we're going to rotate this about the x-axis. Now I want to draw this area a little bit bigger. So maybe it goes like this and it goes like that. And they meet right there when x is 1. And we're going to rotate about the x-axis. And 1 squared and 1 cubed is 1. That is, in case we need it, this point is 1, 1. Now, we only want to revolve this area in between, but we don't have a way of doing that. So what we're going to do is we're going to revolve the whole strip, these strips, all of them. So they're horizontal, those are dx's. So it's going to be, and the strips are going from 0 to 1. What we're going to do is we're going to, so it's going to be pi times the radius squared. Now, what is this radius? Well, that's the curve y equal x squared. So this height is x squared. It's going to be pi r squared dx. But the problem is that when we revolve this, we're going to get the piece we want. We're going to get that volume. But we're also going to get the yellow volume. Over here, we're going to get what we want, but we're also going to get what we don't want. And that's going to keep happening. We get what we want, and we don't, and we get stuff that we don't want. But we can take away what we don't want, because that's just the volume that's generated if you revolve this curve, y equal x cubed, around the x-axis. So that's going to be pi times the integral of the radius squared dx. It's still dx because they're delta x's. They're delta x's. And x is still going from 0 to 1. And the radius this time is this height, but that height is x cubed. So you get pi r squared. Now, for the record, you can just write this as x squared squared minus x cubed squared all dx. And x is going from 0 to 1. So you get the pi times the integral from 0 to 1. X squared squared is x to the 4th minus x cubed squared is x to the 6th. Very, very simple integrals. So it's going to be x to the 5 over 5 minus x to the 7 over 7 from 0 to 1. Plugging in 0 is going to give us nothing. So when we plug in 1 for x, 1 to any power is 1, minus plug 1 in for x, 1 to any power is 1 over 7. That's going to be, inside is going to be over 35. So I have to multiply by 1 as 7 over 7, and over here as 5 over 5. So this numerator is 7 minus this numerator is 5. So the final answer is 2 times the pi over 35. Let us try some more. Just keep doing these. Suppose I tell you that I want to revolve the area bounded by the curve y equals 2 and y equals 4 minus x squared, and we want to revolve about the x-axis. So what volume do we get? Again, this is just negative x squared plus 4. So I know how to draw negative x squared. I just bring it up 4 units. There's 4. So that's this curve. That's this curve. And y equals 2, well, that's this curve. Okay, so the area that we want to revolve is this area. And I need to know what that x value is and what that x value is. Because when I draw my, since I'm revolving around the x-axis, which is horizontal, the strips need to be vertical. Of course, I have delta x's. Okay, so, to find out these points of intersection, I just let 4 minus x squared equal 2. Take away 2 from both sides. Left side is 0. So that must be 2. Because 2 minus 2 is 0. So that which is not x, it's x squared, must be 2. Well, what number or numbers, if any, when you square them give you 2? The answer is routine. It's always plus or minus the square root of that number. And I don't know the square root of 2, which is good. I don't have to figure it out. It's plus minus root 2. Okay. Now, this graph is very, very symmetrical. That is, if I just revolve this piece, and whatever area whatever volume I get, I'll double it. So, how about it's the volume? The volume will be not pi r squared, but we'll do 2 pi, the radius squared, and we'll only go from 0 to radical 2. We can go from negative radical 2 to 2 and not double our answer, but let's not. Okay, now we need to figure out what the radius is. So, since I drew on this so much, how about we get a nice clean picture and we go again. This is y equals 4 minus x squared. This is y equal 2. So basically, and we're not going to worry about the left half. So basically, when you revolve about the x-axis, what is from 0 to square root of 2, what you're going to be revolving will be this. That is what you're going to be revolving. So this is going to be one of those subtraction problems, because you don't want that area, that volume. So it's going to be 1r squared minus another r squared. Okay. Which is not a big deal. So it's going to be 1r squared minus another r squared dx. So the question is, how long will that strip be? And the answer is, it's going to be y. It's going to be y. Minus, how long is this strip going to be? It's going to be 2. It's always 2. It's always 2. The other height is changing. It's that height. Now it's higher. To the far right, now it's lower. But that height is always going to be 2. Okay, and we're almost done. The only problem is, if that's x, you can't have a y. But we have a way to convert y's to x's. So it's going to be 2 pi from 0 to radical 2 of that squared, 4 minus x squared squared minus, I'll leave it as 2 squared dx, because I didn't square anything yet. So this is going to equal 2 pi, the integral from 0 to radical 2. When I square that, I get 4 squared minus 4 times x squared times 2, which is 8x squared. Plus I squared the x squared, which gives me x to the 4th. Minus 4 all dx. Well, 16 minus 4 is just 12. So the antiderivative part will be the integral of 12 dx is 12x minus the integral of that is 8x cubed over 3 plus the integral of x to the fourth is x to the 5 over 5 from 0 to radical 2. Again, all the numerators have an x and the denominators do not, a factor of x. So when you plug in 0, you're just going to get 0. So you're going to have 2 pi times 12 radical 2 minus, well, let's look at this on the side. You're going to have 8/3 times the square root of 2 times the square root of 2 times the square root of 2. Well, that's 2. So you're going to have 8 times 2 times another radical 2 over 3. So it's going to be 16 radical 2's over 3. And now you're going to have square root of 2 to the 5th power. 1, 2, 3, 4, 5. Well, that's 2 times another 2 times radical 2. That's 4 radical 2 plus 4 radical 2. And let's not forget we're dividing by 5. Okay. Now, if there's anything good about this problem, it's that I can factor out this unfriendly square root of 2. It's in every term. So I just need to find out what 12 minus 16/3 plus 4/5 is. Elementary problem. The common denominator is going to be 15. So let's factor it out. The 12 needs to be multiplied by 15 over 15. This fraction by 5 over 5. And this fraction by 3 over 3. Always multiply by 1. 12 times 15 is 180. Minus 16 times 5 is 80. But if you don't know that, 5 times 10 is 50. Plus 30 more, that's 80. And then 3 times 4 is 12. So we have 2 radical 2 pi over 15. 180 minus 80 is 100. Plus 12 is 112. Now, the only numbers that go into 5 other than 1 are 3, 5, and 15. Well, 5 doesn't go into that number. And the only numbers that 15 may go into are, 15, 30, 45, 60. They're going to be numbers that end in 0 or 5, which is not that number. And if you add up the digits 1, 1, and 2, you get 4. And 4 is not a multiple of 3. So 3 won't go into it, which is good. 112 times 2 is 224. Square root of 2 times pi all over 15. Hopefully I didn't make a silly error anywhere. That is always possible. But it's the concept that matters. Okay. Suppose you have y equal x squared. X is positive, and you want to revolve about the y-axis this time. Well, if x is positive, let's not worry about what happens to the left portion of this graph. So it's going to be this. It's going to look like this, and let us say something a little bit different. Instead of just x being positive, x is between 0 and 4. So even that I don't like. Let me just think for a moment. How about, all right, sorry about this. How about we say that y is or equal to 4? So you have, and x is positive. Okay. So we're in quadrant 1 or 4, because that's where x is positive. We have y equals 4, and we're in quadrant 1, and it seems to me like we're in here. This is y equals 4. Here's a 4 right there. So that's the graph, and we want to revolve this about the y-axis. Well, the y-axis is vertical, so we're going to put our strips horizontally. Ooh, that's a delta y. Okay. And notice that the lowest strip is y equals 0, and the highest strip is y equals 4. So the volume is going to be pi times the integral, y goes from 0 to 4, of the radius squared dy. Well, it goes from 0 to x, the radius. This length is x, but x is the square root of y. Why did I keep the positive square root of y? Because in our case, y is positive. So it's the square root of y. Instead of x, I have to write it in terms of y. Now, there is absolutely nothing wrong if you initially say x. That is perfectly fine. You didn't make any error at all. But in the end, before you integrate, if that's y, get rid of x. X is the square root of y. And then when you square that, you just get y. So you have pi times the integral from 0 to 4 of just y dy. And that antiderivative is easy. It's pi squared over 2 from 0 to 4. Let's factor out the pi. If you plug in 4, you get 16 over 2, which is 8. And if you plug in 0, you get 0 squared, which is 0 over 2, which is 0. So the final answer is 8 pi square units. That's what you would get if you did that problem. So now, let us do this problem. Suppose your region is bounded by 2x squared, y equals 0, x equals 2, and there are different parts. Say part A, you want to revolve about the x-axis, part B is the y-axis, and part C is about the line x equal 2. Okay, so let us draw our graph, our region, our functions. There's 3 functions. Y equal 2x squared. It goes like that. Y equals 0 goes like this. Y equals 0. Let me just label the axes. And finally, x equals 2. X equals 2. That's the area bounded by, let x equals 2 be in this color. That's the area or region bounded by the pink, the green, and the blue lines. So that's the area that we want to revolve for part A about the x-axis. Okay, fine. Got it. Now, if we're revolving about the x-axis, which is horizontal, and we're using the disk method, the strip has to go vertically. So the volume is going to be pi times the integral of r squared, and that's, oops, not our dx, but that base is, the length of that base is a delta x. So dx. And x is clearly going from 0 to 2. And the r value, the radius, is just going to be y. Which y? Y equals 0? No. The green curve. Y equals 2x squared. Pi r squared. So it's going to be 2x squared. And when you square that, you get 4x to the 4th dx from 0 to 2, which is real simple. It's going to be 4x to the 5 over 5 from 0 to 2. And let's not forget that pi in front like I just did. So what we're going to get is pi times, remember, there's a 4 here. When you plug in the 2, 2 to the 5th is 32, times 4 is 128 over 5. And when you plug in 0, you're going to get 0. So it's 128 pi over 5. Can't be reduced. That is the answer to part A. That's part A. Now, part B, they say do the same problem, except revolve about the y-axis. The y-axis is horizontal. Sorry, is vertical. So what we're going to do is draw horizontal strips. We're going to draw strips that way, which is a delta y. Okay, so it's going to be the volume is equal to pi times the integral of the radius squared dy. And the lowest one I can draw is when y is 0. Okay, so it's going from 0. What's the highest one I can draw? Well, it'd be good if I knew what point that was, what height that was. Because whatever mark I have here, that's going to be the highest one. Well, they're telling me that x is 2. So to find that height, that's y of 2. It's 2 times 2 squared, which is 8. So it's going all the way up to 8. From 0 to 8. Now, what is the radius? What is the radius? How long is that piece? How long is that piece? That's what we want to know. How long is that piece? Well, given that this is x, given that that's x, and that this mark here is 2, given that this mark here is 2, if I want to know how long that is, if I want to know how long that distance is, well, it's the right end point minus the left end point. It's simply 2 minus x. And I have to square that. 2 minus x. Problem is, oops, that's not x, that's pi. The problem is that says y, and you can't have x's. So it's going to be 2 minus x squared dy. But what is x? Well, what is x? Okay, so this tells me that y over 2 is x squared. So then y over 2 square root is plus or minus x, but x is positive over here. X is positive. So x is the square root of y over 2. Got it. It's the square root of y over 2. Perfect. Okay, so this is the integral from 0 to 8. Let's square this. You get 2 squared, which is 4, minus 2 times the square root of y over 2 times 2. Well, that canceled out, so you get 2 radical y, plus you get that all squared. So it's y over 4. And in anticipation of taking the integral, I'm going to change this square root of y over here to y to the half. Okay, so the integral of 4 with respect to dy is 4y minus 2. You add 1 to that power, you get y to the 3 halves divided by 3 over 2 plus y squared over 2. So 2 in the bottom times the 4 already in the bottom. This goes from 0 to 8. Okay, let us see what this gives us. Pi, you plug in 8, you get 4 times 8, or 32. Now, this here is, including that 2, sorry, that's 4/3. Now, what is 8 to the 3 halves? Oh, I thought that was doable. Okay, so you get 8 to the 3 halves. And then for the next term, one of those 8's will cancel. Get a squared over 8, which is just 8. Okay, let us see how we can simplify that a little bit. You have 8 to the 3 halves, but 8 is 2 times 4 to the 3 halves. Now I'm going to write the 4 first, sorry. So that's 4 to the 3 halves times 2 to the 3 halves. Now, what times itself 2 times gives us 4? 2. Cube the 2, you get 8 times. I have no idea. Well, what do you multiply by itself 2 times to get 2? And the answer is the square root of 2. And it tells something's bothering me here. 4 times 2. Okay. And you have to cube that. So you get that. Square root of 2 times square root of 2. Well, that's 2 times 8 is 16 times the last square root of 2. So this piece here becomes 16 square root of 2's. Alright, so we're almost done. You have pi 32 plus 8 is 40 minus 4 times 16 is 64 square root of 2 over 3. And that's the volume if you rotate about the y-axis, part B. So all of this mess and some side work on the bottom, that was part B. So let us get rid of this. Now we're going to revolve about the line, we're going to revolve about the line x equals 2, part C. Now, I'm a bit confused right now. What I'm confused about is that I just did x equals 2. I'm sorry. X is 2 and the y-axis. See, I'm saying I'm revolving around, I know I didn't, but if I'm revolving about around x equals 2, this curve Well, then that's going to be the radius. I don't know what I was thinking about. That was part B. X equals 2. We're revolving around x equals 2 because that's the radius, and the radius is 2 minus x. Okay. Now we're going to revolve about the y-axis. That's a very big mistake. Now, the strips have to come off of the y-axis, because that's what we are revolving around. So the strips have to go like this. Okay? And then we're going to have to take away that part of it. We're going to have to take away that part. So now we're doing part C. The volume is going to be pi times 1 radius squared minus another radius squared, and we have to even decide if it's dx or dy. Since the strips are going left to right, that's a delta y. Okay, that's a delta y. And the strips, they're starting way down when y is 0, and they're going all the way up to y equal 8. So that tells us that we're integrating from 0 to 8. Now, what is the bigger radius? The part that gives us what we want. Remember, we want this part. That's all we really want. But we're going to rotate all of this. And that distance is 2 minus 0. That radius is always 2. Minus the other radius squared. How big is that piece? Well, that's always x. This distance is always x. But x is the square root of y over 2. The square root of y over 2. And like I said earlier, we're integrating with respect to y. Okay, so routine from here. Let me not put a bracket yet. So it's the integral of 4 minus y over 4 dy from 0 to 8. This is a pretty standard integral. The integral of 4 dy is 4y minus y squared over 8. And this goes from 0 to 8, and it turns out that if you plug in y equals 0, you get nothing. So we just plug in 8. 4 times 8 is 32. 8 squared over 8 is 8. You subtract those two numbers, you get 24. So the answer to part C is 24 pi. Now, let us try one more where we don't revolve around the x-axis or the y-axis, especially since I messed up that last one. Suppose you come to know y is the square root of x. The region is bounded by y equals square root of x, y equals 0, x equals 4, and we're going to revolve about the line x equals 6. Okay, so let's graph this. This here is the square root of x. This here is y equals 0. And this here is the line x equals 4. So the area in question is that area. Okay, so let's get rid of this little piece here. Now, we're going to revolve this about the line x equals 6. Again, we just want to revolve this area in here. Nothing more, nothing less. Since the line x equals 6 is vertical, the strips we're going to use for the disk method is going to be perpendicular. The strips are going to go this way. Okay, and the lowest strip is going to be where y, so this is delta y. The lowest strip is going to be where y equals 0, and the upper strip, the highest strip, is going to be there. Well, where is there? Well, we know x is 2 right here. Sorry, x is 4 right there. So y is the square root of 4. That is, the highest is going up to is 2. Okay? So it's going to be, the volume is pi times the integral, dy. It may be the difference of 2r squared, an r squared and another r squared. But y is going to go from 0 to 2. Now, the problem here is that I didn't draw this long enough. The problem is that, okay, excuse me, I didn't need that. So, yikes. So, the thing is, we don't want this. We don't want that. But we don't have a way of getting to just calculate what's in the in the pink. So what we're going to do is the following. Now, let's concentrate on that point there. How long is that piece? That's what I want to know. Well, this is some x value, and this is 6. So the radius is going to be 6 minus x. Problem is that we have dy's. Well, if y is equal to the square root of x, that means y squared is x. So the radius is 6 minus y squared. Okay, that's the long one. 6 minus y squared. But now we need to take away something. So right now, with 6 minus y squared, we're going to, first of all, let's get rid of this silliness. When it comes to 6 minus y squared, we're going to revolve all of this around the line y equals 6, which is good because we're going to get the volume that we want, but we don't want this volume. Now, there's a couple of ways of doing this. You can realize that it's always length 2. It's 6 minus 4. Every strip that we want to remove is of length 2. So this will be minus 2 squared. Okay, so what we get is pi times, let's square that. We get 36, 6 squared, minus 12y squared, plus y to the 4th, minus 4. That's going to make that 32 dy. And y is going from 0 to 2. So this gives us, well, the integral of 32 dy is 32y minus 4y cubed plus y to the 5 over 5 from 0 to 2. Once again, if you plug in 0, you're gonna get 0. 32 times 0 is 0. 4 times 0 cubed is 0, and 0 to the 5th over 5 is 0. So just plug in 2. 32 times 2 is 64 minus 2 cubed is 8 times 32 is 32 plus 32, which is 2 to the 5th over 5. Well, this equals, that difference is 32 plus 1/5 32. So so over here we have 132, and over here we're adding 1/5 32. Well, just like if you had 3 32s and you're adding 4 32s, this is 7 32. Just like 3x plus 4x is 7x. I'm just telling you what x is. So if you have 132 and you're adding 1/5 32, you're going to have 1/5 32s, which is 6/5 times 32, which is 192 over 5. 192 over 5, which is 192 pi over 5. That is the answer. Now, I said that there was a second way of doing this. If I had left this at 36, that would be 36, and that would be 36. So it's going to be 4 more. It's going to be 4 more. And, oh, okay, that creates a headache, but all right. So we're going to have 1 times 36 plus 32 over 5. If I multiply that by 5 over 5, I get 180 over 5 plus 32 over 5, which is 212 over 5. That's what we would get if I did not take away the 2 squared, which represented taking away what's in green. But we do have to take it away. Now, all I'm saying is, what's in green? Well, you know, I can move this volume I can move it wherever I want. I mean, basically, the base is 2, and the height is also 2, and I'm spinning this around. Doesn't matter that I now have it spinning on the right. I mean, I can tell you that this is 6, and this is 4, and it goes up to a height of 2, and that I'm rotating around this line. That's going to be a cylinder. If you just take a line, you don't even need this piece up here. If you take that line and you rotate it about this line, x equals 6, what you are going to get is a cylinder. Now, this distance here, that's the radius. The radius of this is going to be 6 minus 4, which is 2. And the height is going to be 2. So the volume of that cylinder is pi r squared h. 2 squared is 4 times another 2 is 8. So that's going to be 8 pi. That's what I need to take away. And I'm hoping that everything works out okay. Now, I do have one slight problem with my answer here. It should be 212 pi. Now, we have over 5. Now, I want to take away 8 pi, but the way I'm going to represent the 8 pi will be 40 pi over 5. And 5 goes into 8 40 times. Sorry, 5 goes into 48 times. So this is going to give me 172 pi over 5. And that is not what I got. So let me go and find a silly error. Okay, so excuse me. So now, if we made that form more. Okay, let's try that again. If we make this number 4 more, that is, we go from 32 to 36. When you plug in the 2, it's going to be 8 more. 36 times 2 is 72. It's 8 more times the pi is 8 pi. Okay, but then I said that the volume of the cylinder was 8 pi. So I added 8 pi and I'm taking away 8 pi. Everything's going to match. I didn't make any mistakes other than maybe over here in my calculation. So you can do it either way. Now, do one more problem. Suppose you have, actually that's not gonna work. Okay. Yeah, okay. So suppose you have this problem. You have that y is equal to the square root of 16 minus x squared. And you want to revolve that curve. So it's that curve and y equals 0. And you want to go about the x-axis. Now, let us look more closely at what this curve is. If I were to square both sides, I'll get that. And if I bring the x squared over, I'll get this. But that's a circle of radius 4. That's a circle of radius 4. When you take this and you solve for y, you get that y squared is 16 minus x squared. That means that y is plus or minus 16 minus x squared. Now, what happened is the plus equation is the upper half of the circle. The bottom equation is the bottom half of the circle. So we just have the top half of the circle. Okay? And I'm saying that, so we know based on what I just drew and what I just said, goes from -4 to 4. That is, it intersects at -4 and 4. And that's obvious. Plus or minus 4, when you square it, you get 16. And 16 minus 16 is 0. And the square root of 0 is 0. Okay. Now, I want to know what volume you get if you rotate this around the x-axis. And I think it's clear that you're going to get a sphere. You're going to get a sphere. And the radius of this sphere is 4. So the volume is 4/3 pi times the radius squared, but the radius is 4. 4 squared is 16 times another 4, that's 64, times pi over 3. That's the answer. Okay, you don't have to do integration all the time. Sometimes the answer is just given. It is just a simple figure, and we know how to find the volume of that figure, just like I did with that cylinder. But now, let us see if we can do this using calculus. Let us actually find the volume using integration. So what we know is this is -2, this is +2, this is 4 up here. Now, so remember, the volume we claim is 64 pi over 3. Let us get rid of this so I can write there. Now, if we're going to spin around the x-axis and we're using the disk method, the x-axis is horizontal, so we're going to make vertical strips. But you know what? And these are delta x's. Instead of integrating from -2 to 2, I'm just going to integrate from 0 to 2. And whatever answer I get, I'm going to double. And we know that the answer is pi times the radius squared. So I just doubled it. Now, what is the radius? Well, the radius is y. But y is the square root of 16 minus x squared. And when I square that, that's an easy thing to square. I just get 16 minus x squared dx from 0 to 2. So there's my 2 pi. You integrate, you get 16x minus x cubed over 3 from 0 to 2. Hopefully you see that when you plug in the 0, you're going to get nothing. So it's 2 pi times 16 times 2 is 32 minus 8/3. So you get 2 pi times 32 minus 2 and 2/3. 2 pi. Well, if you have 32, when you take away 2, you're at 30. You take away 2/3, you're at 29 1/3. Now, this is 2 pi times 87/3. And this is 174 pi over 3, which clearly is not what we got. So once again, let's see what's going on. Okay, I see 2 mistakes that I made. One at the very end. 29 1/3 is not 87/3, but rather it's 88/3. So then this should be 176. 176 pi over 3. The other mistake I made was disastrous. I'm saying that the radius here is 4, but here I'm saying it's 2. No. That should be -4 and 4. Which really means that almost everything is correct, except that upper limit should be 4. And I guess it didn't matter that other error that I caught. Okay, so I need to plug in the upper limit of 4. So now when I integrate, the 2 pi factors out and I get 16x minus x cubed over 3, but this goes from 0 to 4. Okay. Now keep in mind that that's 4 squared. So I have 2 pi times 4 squared times another 4. That's 4 cubed. Minus 4 cubed over 3. So 4 cubed is 64. but I have 1 minus a third of them. I have 164 here, and I'm taking away 1/3. So this is 2 pi times 64 times 2/3. This is 256 pi over 3. Now, I did make one other error. This was not the volume. I cubed 4 incorrectly. The volume is 4/3 pi r cubed. R is 4. Fair enough. 4 cubed is 64. But when you multiply it by 4, you get 256 times pi over 3. So in this little space, I got the same answer as that I finally got using calculus. Okay. There's different ways of doing different problems. They don't all involve using calculus. We have the formulas for the volume of a sphere. What might be a good thing to do, and I'll do that right now as a bonus, is to derive the volume of the sphere. You have x squared plus y squared equals r squared. Let's just have the upper half. So y squared is r squared minus x squared, and y is, the upper half would be this. So what we have is, and I won't mess up this time, negative r to r. Now, we want to rotate this around the x-axis. Now, there's no point in doing that half, because I'll just double it. It's pi times r squared dx, because that's the delta x. And I'll double it. Instead of going from negative r all the way to positive r, I'll just go halfway. I'll go from 2 to r. I'll go from 2 to r. And each vertical strip, its length is r. It's the square root of r squared minus x squared. So I have 2 pi. When I square that, I get r squared minus x squared dx from 0 to r. R is just a number, just the value, the radius of a sphere. So I have 2 pi in front, and when I integrate, I get r squared x minus x cubed over 3, and I integrate from 0 to r. So I get 2 pi. Here, I get r squared times r, which is r cubed, minus 1/3 r cubed. So I have 1 r cubed, and I'm taking away 1/3 of r cubed. How many r cubes do I have? I have 2/3 r cubed. And there it is. 2 times 2 is 4, times pi is pi, times r cubed over 3. That is the volume of the sphere. Not because I told you, not because of any of your teachers told you, but because we derived it. That's what math is all about, deriving things. And we just derived the volume of a sphere. I will give you one more using the using the disk method. If this is the axis, and you put a line like that, and now you rotate that line about the x-axis, what you are going to get is a cone. And suppose that the radius of the cone is r, and the height is h. That is, on this number line, this is hr. So that line is r over hx. And I can show you that's true. I know 2 points on the line. 0, 0 is on the line. And r over h times 0, yep, that gives me 0. That point's on the line. And if I plug in h for x, I get y is equal to h over r times h, and I get r. So that point's on the line. So now I want to revolve this line, this green line, about the x-axis. So what do I know about that strip? Well, first of all, it's a delta x. So the volume is going to be pi times the integral of r squared dx, and x is going from 0 to r. So when this strip is near 0, this last strip is at r. Now, the question is, what is the radius? Well, the radius is always y. The radius is r over hx. Okay? So that's pi 0 to r squared over h squared times x squared dx. Now what I'm going to do is factor out the constant, pi r squared over h squared, the integral from 0 to r of x squared dx. And the question is, what is that integral? Well, it's going to be pi r squared over h squared times x cubed over 3 from 0 to r. Okay, and this gives me pi r squared over h squared times r cubed over 3. Okay, once again, we have a little problem, just minor, fortunately this time. X is going along here. I mean, I saw r here, so I said r. It's going from 0 to h. H is that distance. So instead of r, it should be h. Instead of r, it should be h. And then we're going to get one change here, and that's it. Let me write that power higher. So when we plug in h, we're going to get h cubed over 3. 2 h's in the bottom, 2 h's in the top, leaving 1 h in the top. Pi r squared h over 3. That there is the volume of a cone. And again, it's not because your teacher told you or I told you. We proved it. Nobody can say, nope, you're wrong. We proved it rigorously. We used integral calculus to prove beyond a shadow of a doubt that the volume of the cone is pi r squared h over 3. Okay, that completes the disk method.